the 2.7 here. Okay, here we go. Okay, so we're going to solve linear inequalities. All right. So here's what those kind of look like. They're going to look. Let's start off here. We'll do some simple ones here. X plus 4 less than 8. So it's going to use something like that where we're using greater than or less than signs. All right. And to represent the answers for these, there's actually 3 ways to do it. One is to use a number line graph. And the next one is to use inequality notation. And the next one is to use interval notation. All right. Now, in the assignment, unless it has changed, and I don't think it has, they're going to ask you to graph the solution set on a number line. Okay. You're not going to have to, you don't have to do that for all of them. I think as long as you know how to do that with a number line, you do a few of them until you feel like you're comfortable with it, and then don't do all of them like that because it's kind of tedious. All right? But let's go ahead and look through this one here. Really all we need to do in most cases is just to treat this like it was an equal sign, not anything different than what we've been doing. All right? So this is just basically a one-step equation. So we'll just go ahead and subtract 4 from both sides. That's going to give us x is less than 8. All right? And this is called inequality notation because it has an inequality in it right there. So when you write it in that form, then it's in inequality notation. All right? So like in most cases, mathematically, that's how you're going to write it, is like that. It should be 4, yeah, you know. I don't know why I'm teaching this class. No. All right, 8 minus 4, thank you, is 4, okay? So this is inequality notation right here. A number line graph is going to look like this. So we're going to draw a number line, put some little dash marks on there, put 4 someplace like this. All right. If it is less than 4, that means that it's not exactly 4, but it's just a little bit less. So to signify that, we put a little open dot around the 4. Notice that this is pointing that direction. That's going to tell you which way you're going to shade. And there's a number line graph representation. All right. When you write the x first, this is always going to point to the direction that you're going to shade. So that's kind of a nice thing. Interval notation is a little bit more complicated, but yet it's used. And I know it comes in another class, but I can't remember if it's 65 or not. I just don't remember where it's at. Interval notation uses parentheses or brackets. In this case, we're going to use a parenthesis to start with. This is numbers less than 4, which means this continues to go on and on and on all the way to negative infinity. So that's what we're going to write here. Okay, so the symbol for infinity is just a lazy 8, so it's an 8 laying down. And then we're going to stop it at 4 and put a parenthesis there. And that's called interval notation. Okay? Well, because this graph or this solution is less than 4, so it continues to go all numbers less than 4, right? You could just keep going and going and going. So that would be negative infinity that way. Because this is infinity, this is negative numbers here. Over here is negative numbers. So we call that negative infinity. Ooh. Positive infinity is the other way, yep.
So an inequality notation would just be a number line without an actual answer. The answer would be the number line. A interval notation, the answer would be negative infinity 4 in parentheses.
An interval notation, yes. So this is inequality notation. That was the first one we did. It's almost an automatic, right? A number line graph, which is what the book wants you to do 20,000 times, okay? But it's very, I mean, it's pretty straightforward. Once you can do some of them, then you should just leave it. Interval notation is using parentheses, and then we'll see in a little bit it's going to use brackets also. So let's try another one here. So let's go with, this time let's make it a two-step equation. So something like that. And I'll represent it all three ways so you kind of get the feel for that. Two-step equation, what would we do first? Subtract 8. Let's see if I can get it right this time. 2x is less than or equal to negative 2. So we have that. And then what would we do? Well, think of it as just an equal sign. Yeah, we're going to divide by 2. Divide by 2. So we get x is less than or equal to negative 1. So there's our inequality notation for that one. All right? So that's my inequality notation because it contains an inequality. If I want to write it as a number line, then I draw my number line there. Put little hash marks on here. Okay? It doesn't matter really where you put the number. I'm just going to put it right there. Since this time x is less than or equal to negative 1, that's what that means, I'm going to put a solid dot on there. Okay, again, it's pointing that direction, so I'm going to shade into that direction. So that would be our number line graph. Solid dot when we have a equal to, open dot when we don't. So there's the number line notation for the interval notation. Again, I'm going this direction, so that's into negative infinity land. So we're going to go parentheses, negative infinity, and negative 1. This time, since it's equal to it, I'm going to put a bracket there. Okay? So to kind of summarize a little bit of stuff, if we have these signs here, that's an open dot. If we have this sign or this sign, that's a closed dot on a number line. This here means parentheses, parentheses. Here, we're talking about brackets. Okay. So you kind of have to look at the sign and see exactly what it is that it's telling you, and then you can apply the correct notation. All right, so let's try. We're going to kind of keep scrolling along here. Let's go with another one. Let's go with 5. Come on. There we go. 5 parentheses x minus 3. Let's go greater than or equal to this way. And let's put in 8 this time. So we'll go with one like this. Okay, so we're going to, let's distribute this inside. So we have that. Then we're just going to add this 15. Oh my goodness. Come on. 5x. Oh, we're going to find one here. It's not going to work, so that's 23. And we'll divide this by 5. Okay, so we're going to get x is greater than or equal to 4.6, I think that turns out to be. All right. So again, we'll write it in all three forms so you kind of see how it's written in all three ways. All right. First of all, here's my inequality notation right there. Okay, there's that one. As a number line, I'm going to draw a number line.
So the only difference with that one would be a solid black dot.
Yes, that's going to be a solid black dot.
But that's the only difference compared to the inequality notation, correct? Which is the hollow dot.
The hollow dot will come when you have a less than or equal to right here. I know you can't see what I'm writing because I'm trying to, but it's not right there.
Sure.
Okay. So that would be open. This would be solid. So in this case, we're going to have a solid.
Right.
Okay. So I'll draw my number line. Okay. Since it's a decimal, I'm just going to go 4, 5, because 4.6 is going to be between there somewhere. I'll put my solid dot this way. And then again, this is pointing the direction you're going to shade. So it looks like that. Now, I don't, however you want to shade it, doesn't really matter. You go like this or whatever you want. All right, so in this case, since we're starting at 4.6 and going in that direction, 4.6 is the number that we're going to start with. Again, it contains it, so that's a bracket. This time we're going to positive infinity, so we're going to put an infinity sign with a parenthesis. Always put the parentheses with infinity because it's not a number. All right, so you just put a parenthesis there. That's how you would write that in interval notation. So there is that, solving those basic ones, okay? They do get a little bit more complicated. Let's take a look at, let's say we have 3, oh my goodness, this thing keeps thinking. 3 is less than 5, all right? If we multiply this or add or subtract by any number, all right, no matter what number I choose, let's say I decide to multiply this by 2, that's going to be 6 is less than 10. Is that still a true statement?
Yes.
Yeah. So multiplying doesn't change anything. If I added 2 to this and this, I would have 5 is less than 7. Is that still a true statement? Yes. But if we have this and I decide that I'm going to multiply by negative 2, gosh dang it, then I'm going to get negative 6 is less than negative 10. Is that true? No. So when we multiply by a negative number or divide by a negative number, this sign has to flip. All right. So when you're solving these equations and you're zipping along, Sunday night, whenever you're doing it, Sunday morning, okay, and you multiply or divide by a negative, you have to flip the sign around. So let's do an example of that. So we have like a negative 3x okay, plus 8 equals, say, a negative 13. Okay, yeah, we'll do one like that. And we subtract 8. Oh, not let's do this way. Subtract 8. That's okay. Nothing changed there. We can add and subtract all we want. All right, but as soon as we divide by a -3, this sign has to flip around to that direction. Okay? Because that changes the inequality. When you multiply or divide by a negative, it's going to change it. We just looked at that. All right? So you have to be aware of that. That is something that could come up, you know, just because you're so used to not having to worry about that, and all of a sudden, boom, you have to do it. All right? So as a number line again, 1, 2, 3, 4, 5. Here we go. I'm going to put 7 right there. Open or solid dot, what do we have? Solid. And which way are we going to shade, to the right or the left?
Right.
Good. Believe me, we're shading to the right here. There we go. Like that. Okay? Interval notation. Bracket or parenthesis, what are we going to have with the 7? Bracket. We have an equal to there, so we're going to have a bracket. 7, positive infinity. Got to have a parenthesis with the infinity. All right. That is your interval notation. Let's see. I'm looking to see. In the book, they throw a comma in here. I've seen it both ways. So that's how you're going to see it there. Okay. All right, let's make it a little bit more complicated. Let's say we have a 2 parenthesis. Gosh, this thing.
I have a question.
Yeah.
How would this work with fractions? The same as just, it would be the same, correct?
Yeah, fractions aren't going to change anything. Okay, so let's say we have something like that. Okay, so we'll distribute this inside. We're just going to treat this just like it was an equal sign here. We're not going to change anything. Okay, we're just going to distribute that inside just like it's an equal sign. And now what should we do? Subtract 4x? Oh, do the 2x? That's a good move because we're not going to have any negatives then, see? That's a good idea. Okay, so then what are we going to do? Yeah, add the 5, good. So now we have -3 greater than 6x. And then to finish it, what are we going to do? Divide by 6. There you go. Okay, so we get x here. We get this guy here. And that's just going to be a half or 0.5, however you want to view it. Okay, we don't have to switch any signs because we didn't multiply or divide by a negative. Okay, so Karina set us up on that. That was good. All right, so there's my inequality notation. All right, if I did it as a number line, draw a number line. All right, I know it's going to fall between -1 and 0. Solid or open dot, what are we going to put there? Open, good. Okay, it doesn't have an equal to, so it's got to be open. Tricky part is which way are we going to shade? Because this says x has to be less than -1/2. So which way are we going, left or right? We got to go left. Okay, because we didn't write the x first, we can't use that little trick that says go shade that way. See? So you got to be careful with that. You could rewrite it. You could say, well, what if I went like this and just rewrote it? And now I could use a little trick. Yep, you could. And interval notation. So this time, Notice that I'm starting with the smallest number, which is the infinity, parentheses, negative 1/2, bracket or parentheses.
Bracket? I don't know.
Because it's just the not the equal sign.
Right. Equal sign is bracket.
Mm.
Okay. Equal sign is bracket. So on the top of your paper, you probably want to write something like this. Okay. So that you know that on that, and then parenthesis, parenthesis, bracket, bracket for the same thing. Okay. So you might want to have that so you can look at it to reference. Okay, so that one had x on both sides. All right. Let's see. Oh, you want to do a fraction one? Let's try a fraction one. X over 3 plus 2 less than or equal to 4. So something like that. What should we do with this one right off the bat?
Carry the x.
Carry it, what do you mean?
Take it over to the 4. Times. Don't listen to me.
That's someone times by what?
Multiply by 3.
You can multiply by 3, right? To clear that bottom.
3 times 2.
Okay, we can multiply by 3. If we multiply by 3, okay, so we're going to go all the way across there. What would this result be right here?
X plus 6.
X plus 6
Less than or greater than 12.
less than or greater than 12. Okay, so now we just solve it, right? Do this, do this. X is less than or equal to 6. Okay, I'm not going to do all three of them there. Once you know how to do number line graphs, don't do anymore. Okay, if you know how to do them, when you get to the assignment, it's going to say, graph the solution set on a number line. But after you do it, then quit and say, okay, I know how to do those, so I'm not going to worry about it.
What if you had an answer like 7/6? 7/6. How would that be graphed on a number line?
So, well, let's look at the one, we had one up here where we had, where was that
I
at?
think we just had 1/2.
I had a 4.6, a 23 fifths.
So you would just do the division and then have it reflect on the number line?
Yeah, so I did a division, so I got 4.6, okay? And then I know 4.6 is between 4 and 5.
Okay.
Okay, so I just picked it. I mean, I'm not going to check exactly and make sure that's 4.6. Right, so it's just somewhere between there. Right.
So you don't want to leave it as a fraction?
Oh, you can. Are you going to be able to know what numbers to put that between? That's going to be my question. So if you get a fraction like 34/7, are you going to know where's 34/7? What two numbers is it between? You see what I'm saying? When you do number line on that?
What if it's like 5/12?
5/12. Yeah, then you would know, huh? Yeah, and you can.
Okay.
Okay, yeah. All right, just when you think you're doing all right here, let's try one like this. Okay, so let's try one like this. Let's distribute this 3 inside here. So we have that. Now what would we do? Oh, here, I want to make this a negative. Let's just make this a plus. That'd be an easy thing. So now what should we do?
Plus 3.
Plus 3
2, 4.
to the 4. 6x greater than or equal to 7 plus 6x plus 1. Okay, now what?
You can add the 7 and the 1 together.
6x greater than or equal to 8 plus 6x. Okay, now what?
Minus the 6's.
Minus the 6x, minus the 6x. 0 is greater than or equal to 8.
No solution?
Why not? Right. So 0 is not greater than or equal to 8, is it? No solution. Good. So just like in the ones where we had that where things canceled out, remember when we graphed them when we said they were, parallel, that kind of thing? We had no solutions. It can happen on these too. Okay? Same thing can happen. All right. Let's see. Let's try I really want to try just one more here. Just even this simpler one here. Okay, so let's say we have one like this. A little more straightforward. So what would we do on this one first? Minus 10. Minus 10. So I have negative 2x is greater than negative 18. Now what? So we're going to divide by negative 2. Divide by negative 2. So x is 9 positive. Okay. Is that right?
We didn't change the sign.
Wait, we got to change the sign, huh? Yep, got to change the sign. Okay? Whenever you multiply or divide by a negative, got to change the sign. See how easy that is? To just go and do them and not have to worry about that, and all of a sudden now you have to change the sign. Okay, so really be careful with that to flip it over. All right. I'll give you a couple of those to practice. Any questions on that part, the solving inequalities? It's very similar to what we were doing. Okay. On the, I'm assuming that everybody has the ratio and proportion, the 2.8 section. Okay. On the 2.8, the solving proportions. Proportions are actually, you probably did quite a bit of those in Math 20s. I know I did. All right. And there's a lot of applications with proportions. Okay. Actually, my wife brought me one last night. She was working on some, she was making some, I don't know what to say. It's food for hummingbirds, and it has a certain amount of water, okay, and sugar, okay. And she said she usually had, I think it was like 5 units of water was 3/4 units. I think it was like cups or something of sugar. She says, well, I'm not going to do the whole thing. I'm just going to go with 3 units of water. I just need to know how much sugar I needed to make. Okay, so since she knows, brings it over to me, right? So I go, okay. So we're going to write a proportion. So we're going to go units over units. I have 3/4 of a cup here, and then I have my unknown quantity right there. So this is a perfect example of a proportion problem. Again, this is one of the most real life skills you can learn, to use proportions a lot. I think they have nursing majors in here, most likely. No nurses? No prospective nurses. Almost always, all my classes have tons of nurses. They do. This is something they do a lot of. So we'll cross multiply. Like this. And I picked 3/4 because that's what she has. So let's see. That's going to be 9/4. And then we have to solve that little problem. Okay. Now we could divide by 5, right? Or we could just multiply by 1/5, because that's another way of doing it. And we're going to get 9/20. Okay, so I don't know what we got. We got some crazy number, and I said, well, it's just a little over half a cup. So this would be just a little bit over, or a little bit under half a cup, right? Okay. But that's a perfect example of a proportion problem, because you just have a lot of them. And when you're solving them, All right, you just set up a proportion. You're going to cross multiply, right, and then divide out. Okay, so most of the problems that you're going to have are going to be like that. Okay, where actually some of them are just going to be straight up solving a proportion, but they might do something like this, where they're going to put an x minus 2 in there, but we're still just going to cross multiply. So let's go 3 times 4, we'll put 12 there. Make sure when you do this multiplication that you not only do the x, but you also do the 2. That's a pretty common mistake, just to go ahead and do the 7 and not do 7 times 2, but you got to do it because it's 7 times the whole thing. So once we get to this point, we'll just solve it out like a normal two-step equation. 3 point something. I'm not sure what 26 divided by 7 is. 3 point. It's about 6 something? 7? 6? Anybody do it? Thanks. Okay. So the extent of the cross multiplying problems are going to be kind of like that. All right. Let me see if I can pick out a couple of on 214, what problems are we doing on there? Does anybody have their syllabus handy? 11 through 20? 7 through 20? Okay. And what else?
29 to 35.
And is there more after that? That's it? Okay. All right. So let's take a look at number 7. Okay. You want to take a look at number 7? We can look at number 7. I definitely want to look at number 29, and then I want to look at 39. Okay, here we go. So 7, it said in a class there are 20 men to 10 women. Find each ratio. First express the ratio as a fraction, reduced in lowest terms. Then rewrite it using the reduced fraction and a colon. Okay, so we want to find the ratio of the number of men to the number of women. So that's going to be, how would you write that as a ratio? What are we going to write? Well, we're going to write 20 because it's got to go men on the top and then women here. Okay, because it's men to women. Okay, so it'd be 20 over 10. But it wants us to reduce that, so that's going to reduce down to 2 over 1. Okay? Then they want us to write that in a colon form, so we would go 2 colon 1 like that. And that's all you have to do there. Okay, so then we just, and then they might have you do 1 to the total. So if we had men to total, then you would have 20 over, what's the total number going to be? If we have 20 men, 10 women, what's the total? 30, yep. So that would be 2/3. And then as a colon, that would be 2 to 3. That's how you would write that. 2 to 3. All right, let's take a look at problem number 29 because that's kind of similar to what we're going to be doing. Let's see. Use a graph to find each ratio. First, express the ratio as a fraction, reduce in lowest terms. Then rewrite the ratio using the reduced fraction and a colon. It's kind of the same thing. This time, though, we're going to have to interpret this graph. It says a number of milligrams of caffeine in a cup of strong coffee to that in a cup of weak. So how many milligrams of caffeine do we have in the strong? What is it? 200? Okay. Over the week? How much for the week? 80. All right. We're going to cross that out and we're going to reduce it. So we have 20 over 8, but we can still reduce that. What's that going to be reduced down to? What numbers can we reduce out of that? So 4 can reduce into that. It's going to leave us with 5, close, 5 halves. Right, that's what you meant. And then as a colon, we're going to write it as 5 to 2. All right. So whatever word they mention first is always the one that's going to go on top. In this case, it was strong to weak. Okay, so we put the strong on the top. All right. Okay, let's take a look at we have to take a look at 39, because that one's always grabs somebody's attention here. Okay, only because of the little caption below there. That's not me. All right, but I did get a phone call one time. Somebody asked me if it was me, and I said no. So, just in case you're interested in that one. Height is proportional to foot length. A person whose foot length is 10 is 67 inches tall. So if I go 10 inches in foot length versus 67 inches tall, we're actually going to be taking a look at something like this in the next unit. In 1951, photos of large footprints were published. Some believe that these footprints were made by the abominable snowman. Each footprint was 23 inches tall, or 23 inches long. If they indeed belong to the snowman, how tall is it? Assuming that they're similar. Okay, so let's write a proportion. So how would we write a proportion? We have 22 feet here. Tall, we don't know. What's that going to look like? All these, I know there's people out here know this because it's in Math 20. Okay, so nobody wants to take a shot at it. Notice what we have two different ways we can do it, right? We have foot and foot. Okay, so let's do it that way. So let's go 10 over 23. All right. What number would I put up here for tall for the 10? That's right. Because those two are related. Okay. So then we put our X down here. Lost my green here. Cross multiply. 10x equals, I don't know what 23 times 67 is. Somebody will have it.
1541.
Thank you. Divided by 10, and we get the answer. 154.1. Pretty tall. Do we need another one with proportions like that? Or do you think you'll be able to set them up? Yeah, I'll be able to set them up. Yeah, I need another example. How about, here's one to be like on the test. Let's see. Let's say we're going to make up some like little trail mix stuff. Okay. And a normal recipe we have, we'll say 10. Oh no, that's not. That's going to be way too many. How about 3 bags M&Ms, because they make that stuff good. Okay. 3 bags of M&Ms to we'll just say 5 units. I don't know what the units would be of mix. Okay, total mix. And we want to know how many bags of M&Ms. To 9 units. We're going to make a bunch. All right. So normally we go 3 bags of M&Ms here. Oh, you bugger. To 5 units of mix. How many bags of M&Ms to 9 units of mix? So let's write a proportion for that. What would that look like? 3 divided by 5.
Equal to x divided by 9.
That's right. Okay, so we went 3 to 5, because that's how many bags, that's how many you had here in the original ratio. We don't know, over 9. Okay. Mix, 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 mix. Mix is on the bottom, M&M's on the top. Good idea. Cross multiply. Divide by 5. And we're going to get 5.4. Yep. Okay. Now, just to confuse you here, we could actually write this proportion in another way too. We could go M&M's over M&M's. So we could go 3 over x equals mix over mix, 5 over 9. Notice when you do that, you're multiplying the same numbers, and it's not going to change anything. Okay? Guess you can't see it because that thing's in the way. Oh, now we're really in trouble. Okay? So, yeah, you can write the proportion actually in 2 different ways. You got to be careful though, make sure that you're kind of keeping your units straight. Here, notice we went M&M's over M&M's, mix over mix. Okay? Here we went this ratio here to this ratio here. So you kind of got to be a little bit careful, and you don't want to mix them up. There is an actual proportion you could write where it wouldn't work. All right, but here we just went M&M's over M&M's, mix over mix. That'll work. Big over small equals big over small when you're comparing things. Sometimes that'll work. All right, but just keep an eye on your units. That ends all the proportion. Do you have any questions on the proportional? Yes.
I have a question.
Great.
Okay, so if the 3/5 is negative, do you apply the negative to both parts when you multiply?
Actually, I don't think you're going to run into a proportion that's going to be negative, because they're usually showing quantities. Are you talking about a proportion in itself, just where you cross multiply, or are you talking about in a problem?
Or on here it shows the negative.
Which? Oh, are you looking at 22 or which one?
On page 214.
Yeah.
A lot of them.
What? Oh, I mean like on 16?
Yeah.
Oh, okay. Yeah. All right. That's a little different. So you're looking at something like 8 over 10 equals 3. Put a negative out in front there, and put an x there, right? Okay. Take the negative, put it with the top number up there,
Okay.
and then do it.
Okay.
Because this actually can apply to either one of these, but in this case it'd be easier to just toss it with the top number, okay? Yeah. But in a problem sense, you shouldn't have any negatives, because you're always dealing with quantities.
Right.
Right, okay.
Thank you.
You're welcome. Any other questions on anything with the proportions? Okay, so what I'm going to do is give you some, typical protocol here. I'll give you some problems to work on. Please go take a break, and then we'll work on those, and that'll be it.